Finally, we are going to add one additional complexity to this model, and we are now going to vary the effect of gender by school as well as varying the intercepts of school. So essentially what we're doing now is we're allowing the slope and intercept to vary across schools while still estimating the overall global effect of female, male on test score. So the way that this is going to look now is that not only do we have our intercepts, our alphas, as J schools with individual subset within those schools, we are now also estimating the effect of being female by school with individual subset within school. This adds quite a large amount of notation, but substantively we'll walk through this and it's not too complicated, okay? So I think it's much simpler to do with the output in hand. We will now only add this additional covariate at the group level, the school level here, by adding plus female. So we have intercepts that are varying by school and additionally allowing those slopes to vary with regard to the effect of being female on our outcome course. So again, as promised, I'm going to walk through exactly what each of those components means. So the residual within school standard deviation is going to be the residual here in the random effects, and that is 13.03. The estimated standard deviations of the school intercepts, and this is across, right, as well as the school slopes, are here. So this is our slopes, and this is our intercepts. Now, in general, I don't think there's much of a rule per se about what is a large amount of variation, because ultimately we want to know, should we be running this multi-level model in the first place? Is it necessary to take into account the potential varying effect of schools on our overall estimation of the impact of being male or female on a test score? And what we can see here, and I guess like the general rule that I try to follow is like this fall down criteria. So you could imagine that if we took 10 and that dropped down, we'd be at 17. Now that would be quite large in comparison to the within school standard deviation that we would be estimating if we just had the intercepts for school, right? So if we just had a factor for school. Now, this is implying to me that it is a good decision for us to model the variance across schools as well as allowing for the effect to vary across schools in our goal of trying to estimate the overall effect of being female on test score. We can also see that the correlation between varying intercepts and slopes is around negative 0.52. So what that signals, right, is as the standard deviation across schools for intercepts increases, the effect, the variation in the effect goes down. So when a school's intercept increases by 1 standard deviation, that school's slope would then decrease by 0.5 standard deviations, which I guess kind of makes sense in the sense that as a school performs better more generally, the difference between females and males will be less. And we can kind of see that here. So again, what we're allowing for is allowing for a difference in where the intercept crosses, as well as now allowing for differing slopes. So you can see that the red and the blue line have the same slope in all of these diagrams. But what we're doing now with the partial pooling is we're allowing the intercept of that line to change as well as the slope. And like I said, it seems like, so for, let's say, this school here, in general, males tend to have lower scores, which means that the increase from going from male to female can be larger. Whereas for schools that already have high test scores, like this one here, the difference between going from male to female is going to be less. So to briefly conclude, in this module, we talked about going from a complete pooling model in which we are not differentiating between schools in this case or any upper level group classification. Then we also talked about how we've done the no pooling, which again would just be a factor by that group, which is something that we've talked about. And rather than doing it in interaction of sorts, right, where we would see how the effect would vary by group, what we're going to do is we're just going to model that variance while still estimating the overall effect of, in this case, being a man or a woman on your resulting test score. So I hope that difference is clear between the traditional attempt that we had before and this new attempt where we are trying to use partial pooling of our variance to allow us to get better estimates of the overall effect that we're interested in, knowing that there is potentially a cross-group and within-group variation that we want to account for as well.